Hi. This is our presentation for the survey paper for the course, Electric Machines. The topic for our presentation is medium voltage switchgears. Introduction. As you know, electricity is one of the most useful and biggest discoveries humans have ever made. Many of our modern devices run on electricity which comes from power stations. Since this electricity has to be used by many consumers, power stations generate a large amount of electricity which has to be transmitted over electrical grids. This generated electricity may pose a danger, since it can cause severe electric shocks and fires. For safety purposes, switchgears are installed which can lessen such dangers. A switchgear is a combination of switches, fuses and relays which is used to protect and isolate connected electrical devices. It can be used to turn on and off connected electrical devices in a system without affecting other connected devices which may be separate from the switchgear. There could be a number of reasons for breaking the circuit and de-energizing the equipment: inspection, maintenance, clearing of faults, or even automatic shutdown due to high currents. History of switchgears. In the beginning, switchgears were wall-mounted, and were mechanically operated. Wood panels were also developed which didn't find much use due to wood being vulnerable to fire. Mercury switches were also developed in early 20th century which consisted of two electrodes dipped in mercury. The mercury could be removed from one of the electrodes to break the connection. Vacuum and SF6 switchgears were developed in the 1960s. These two enjoyed fame and prevailed over other types of circuit breakers of that time. Even to this day, vacuum and SF6 switchgears are used. Construction of switchgears. Switchgears have two types of components: electrical components and control systems. The control systems consist of control panels and sensors for monitoring and sensing of electricity and the internal electric circuitry. The control system controls the electrical components and helps protect them from damage. Displays are also included for ease in operation. The important electrical components include circuit breakers for stopping the current flow, contactors which act as conductors for switching, protection relays for smaller components inside the switchgear, capacitors for maintaining power factor and reducing the reactive power, and switch fuses for preventing any abnormally large currents. Working of switchgears. Even though all switchgears have the same purpose, different types of switchgears have different mechanisms for breaking the circuit. The main problem is electrical arcing, which occurs when two highly energized conductors or contacts separate. Electrical arcing is the electrical breakdown of a gas that produces an electrical discharge. It can damage the internal components of the switchgear and cause fires. Vacuum switchgears tackle this by insulating the contacts in vacuum. No arcing can occur if there is no gas to ionize. In SF6 switchgears, sulfur hexafluoride gas is passed over the contactors when they are separated in order to absorb the ionized particles and thus prevent the electrical arc from forming. Applications of switchgears. Switchgears are basically just circuit breakers that operate at higher voltages of the order of 1 to 100,000 volts. They are used in various places, but mostly they are employed in generator circuit breakers, station switch breakers for isolating the load from the transformer, distribution switchgears, in industrial applications for isolation and protection of various motor drives and electrical devices. They are also used in remote areas like in rural ones where climatic and weather changes can cause faults that last for a small time. These switchgears are able to discriminate between faults that last long or have a small duration and deal with them accordingly. Grounding circuit breakers are used when bus bars and incoming and outgoing feeders are to be grounded for maintenance work. The end.